this week for some of you. If you are not retesting, then this week will be pretty chill. But if you are retesting, remember the window is Wednesday and Thursday to get all of those Unit 1 and Unit 2 retests done. You can come to multiple if you need to take multiple of those because they're only 30-minute windows. If you made below a 70 on something that you're retesting, you need to come in and go over your test with me. That's mandatory. And if you're just like retesting, like, 75 trying to get a 90, you can come in if you want to, but it's kind of on you. Just in case for preparing, since I've kind of cleaned up Canvas, I do have all the Unit 2 stuff, but I'm probably going to take that off today. If you want to go back and look at anything, if you go to this previous unit, I have like the old calendars of each one. So like it's been a minute since we saw systems. If you click here, it has like everything from Unit 1 like on there. I just copy and paste it when we're done. Same thing with Unit 2. So that's in the previous. I just don't want it to get like too messy with all the current stuff. We are moving on though. We are starting absolute value functions today. We have kind of a short lesson. There's no Delta Math with today's lesson because it is transformations. I have another paper for you. But we also have to do something else today that will involve your Chromebook. Okay? So I'll talk about that towards the end. It's not like a graded thing. It's just something that we have to do. I'll talk about it later. I would like to point out as we start this new unit, and this absolute value is going to be your final grade in this quarter, this first quarter. I'm noticing that there's a strong correlation between people who are not keeping up, not necessarily. There's some outliers with this. But people that are not keeping up with like the required practice, which has basically been Delta Math, or people that are not doing test reviews, and then the number of retests that we need. Do you see what I'm saying? So it's like, okay, some of the tests that were like failing grades. I'm like, did you do the review at all? No. Oh, gosh, wonder why. Okay, so moving forward, starting fresh in this new unit, it's important to stay on top of your stuff. It's important to take these CFUs. We have like 3 of them, valuable, and be ready for them. So that way you kind of know what to do before you get to our Unit 3 test, which is on the week of the 2nd. Okay, so keep that in the back of your mind. Like, this class is going to build. We don't slow down. So, yeah, there's that. We want to finish strong. Okay, we are going to be transforming and graphing. Do y'all want rulers today to graph? Anyone want a ruler? If you want a ruler, blue little bin over there. Let me go grab it. Focus back in. So we are studying in this unit. This unit is all about absolute value. Today our focus is transformations, but then we have a couple days on actually solving these equations and inequalities. So this next test is actually going to be 3 grades, okay? Transformations, equations, inequalities. You'll see the breakdown on Canvas. And it's broken down by topic, okay? So just to review, we need to kind of understand the way that this graph works and how to move it before we get into actually how to work with these equations the next couple classes. So here's our absolute value parent function. Do y'all know what it means to be a parent function? Parent functions are just like the most basic version of that graph. So like with linear functions, it'd be like y equals x. Slope is 1, y-intercept is 0. It's just the most like basic that you can get. There should be arrows on this graph, but this is what your absolute value parent function looks like. This is the equation for the parent function, y equals the absolute value of x. And it takes on this shape because of the definition of what absolute value is. Your absolute value is the distance from 0 on a number line. So that's why this graph doesn't have any negative y values, because it basically, when you're looking at the absolute value of -1, that's only 1 unit from 0. So that's why it's -1, +1. You're just taking the absolute value of each input to give you your output, okay? It's the reason why the negative goes away is because, again, it's a distance, and distance is always positive. So these are the points, and these points are kind of like, when we did transformations last week, we would always get like a little, we call them like a monster or whatever. You would get a function, and it would have all these original points, and then you would like do transformations to that. This is the guy we're going to be transforming the whole time. He's a lot more basic, The points are pretty straightforward, but we're going to do all the same transformation rules that we learned last unit, and you guys did well on, but just with this particular graph. So you're going to have some arrows, you're going to have this point right here, and so there's some vocab that we want to talk about, and vocab I feel like is something we really need to work on. I'm noticing that our math vocabulary can improve. So here are our new vocab words. First one is vertex. Of the parent function, I'm always going to ask you for the vertex of the graph. Your vertex is your minimum or your maximum point. It's kind of like that sharp turn on your absolute value graph, okay? Because there's not much else they can do. They can slide, they can flip, but they're pretty much going to be like a V. The only other thing is they'd be like upside down, okay? And so that point, that minimum or maximum point is your vertex point, and that's where all your symmetry is about. I'm going to write min or max points. I'm emphasizing that the vertex is an actual ordered pair. Now, on the parent function, that ordered pair is 0, 0. As we transform this graph, that will change, okay? So all of this is based off of the parent function. I'm going to make another note here. Parent function, okay? Then when it says minimum value, I don't know if I'm going to ask you to do this that much, but just so you know the difference, again, the vertex is the entire ordered pair. It's a maximum or minimum point. In our case, it is a minimum with the parent function. If it asks for just the value, you just grab the y value, okay? So if the vertex is a point, the value is just the y. This parent in particular does not have a maximum value because the parent function just goes like this, and so there's no maximum. Another vocab word is axis of symmetry. So your axis of symmetry, I'm going to draw it in blue right here. Your axis of symmetry is the vertical line. I'm drawing it dashed because it's not actually on the graph, but it's the vertical line that cuts your graph in half. It goes directly through the vertex. So if you know your vertex point, then you should know where your AOS is going to be. We also abbreviate it AOS. Oh, not AO. Ugh. AOS, and it's going to be equal to a number. It's going to be X equals a number. So we'll also have you write that. It has to be written as X equals, and I am particular about that because it's an equation of a line. And it's a vertical line, that's why it's X equals. This graph we would say is concave up because it's opening up. If it's concave down, it's going to open down. The domain, here's the best thing about domain of these graphs. The domain, arrow on the left, arrow on the right, that's negative infinity to positive infinity. I'm okay if you guys start writing this. What does that mean?
Real numbers?
All real numbers. Okay, so you can either write it as interval like they did. You can write it as all real numbers. That's fine too. All real numbers. Your range, however, is not all real numbers because there's a boundary on it. So the range of our parent, it goes from the minimum value to positive infinity. And of course, if it's opening down, that can be different. These graphs, this is just kind of review. They increase and decrease, so it kind of shows you what the interval, again, everything on the first page is about this parent function. It increases in this little branch, it decreases in this little branch, so they wrote that out. And then it's never negative. However, there's a stopping point at where it's positive. Why do we have to stop at 0 for being positive? 0 is not positive. Okay, so this is kind of review. I'm more going to be harping on this kind of stuff at the top. But again, vocab is important. We want to be able to describe our graphs like with all of these words. Okay? All right, flip over. Your favorite letters. Here they are again. We're going to abbreviate through this. Okay? Please save your whining for later because I don't want to listen to it. All right, fill out what you know. Fill out what you know. We can abbreviate. Do you want to fill it on your own or you want me to do it?
You can do it.
You're gonna have to write it though. You're gonna write it while we talk it?
Yeah.
Okay. All right. So if A is less than 0, that means if A is negative, what does that do? Flips how? Reflects the x-axis. Okay, it is a vertical reflection. I prefer to say the axis. I don't know. It's just like me, but in case you know the other way. All right, if the A value is between 0 and 1, I'm going to abbreviate. If your A is between 0 and 1, vertical, because it's an A, between 0 and 1 is like baby fraction, so that makes me think it's a compression. Do you have to change the factor with an A value? No. If A is greater than 1, that is a by A. And again, notice where A is. I do not. Okay, take your pencil. I don't like this. Get rid of this guy. Blech. Ugly, ugly, ugly. Okay. All right, we like this one. I'm going to highlight the one that I like. So what's a little bit different now is you'll see that instead of that like F parentheses, blah, blah, blah that we had on our last packet, now I actually have a function in there. I've got my absolute value bars. So it's really easy to see now inside versus outside. So you'll see that A and D, those are outside. And I'm talking about outside of my absolute value bars. And then B and C, those are inside my absolute value bars. Okay? So we're always transforming from that absolute value parent function. Okay, the other vertical transformation is transformation D. This is the easy one. If it's positive, then that means you're going up, however many that number is. If it's minus D, you're going down. All right, the not so fun one is your B value. Let's remind ourselves about B values. These guys, I told you I wasn't going to test you last time on it, but I'm going to today, or this unit, you'll see it. Your B value has to be factored out. Write that down, and I'll show you what I mean in these examples. B must be factored out. B must be factored out is what that says. I'll turn it sideways in case you can't see. Factored out. It's like undistributed. Okay, we're going to divide it out. If it's not like that, we have to fix it first. And that has to be like step one. Is a very important. You're going to get the rest of the stuff wrong if you don't do that. Okay? All right, this one. If you have a negative B, it's on the inside. What kind of reflection over which axis is that? Reflects the Y axis. That's horizontal. All right, remember, with the B value, you have to take the factor that it's being stretched or compressed by is the reciprocal of that. So, if you have a fraction in there, a fraction less than 1 in there, when you reciprocal that, it's going to become what? Bigger than 1. Okay, so if your B value in the function is between 0 and 1, this is actually going to be a horizontal stretch by the reciprocal factor. Which again, if it's a fraction, when you reciprocal it, it'll be a whole number. If it's greater than 1, it's a compression, which this isn't something that I typically have like just memorized. I just need you to know how to apply it. And then we have our slides with C. So if you have plus C in there, then that means you're going to the left. Minus C means you're going to the right. So again, I told y'all you were going to have to learn it. It's going to be the same letters all year long. You're probably going to fill this out multiple more times this year. Okay? So it should be to where hopefully next time y'all can do it on your own. Okay? All right, so here we go. We're going to go through and work some of these graphs. There's a lot. There's a couple that I want to talk about. And then we've got some writing. And then we'll call it a day and do this little thing we have to do. So look at, again, this is, transformations is its own test grade this go around. So this is really important that we know how to do it. This is really important that you know the general shape. The parent function, again, the points are already on here for you. So yay. And then we just have to go through and find all this stuff. Okay? She wrote it in the notes like in function notation or just like straight up absolute value. I think we can just look at the absolute value one, but just to see how you can put it in general, whatever. Okay? All right, here we go. Number 1, y equals absolute value of x minus 2. Is that minus 2 an A, B, C, or D? C. That's a C. So what transformation is that? right 2. Okay? So in my rule, we went back to where we kind of split the table. What do I need to do to each of my x's? Add 2. Move them to the right. Am I changing my y's at all? No. So your y column is going to stay the same. 2, 1, 0, 1, 2. And then your x's, this is like so easy. We should have skipped this one. All right, negative 2 plus 2 is negative 1 plus 2. 0 plus 2. 1 plus 2. 2 plus 2. All right, new points. Let's plot them on the graph. 0, 2, 1, 1, 2, 0, 3, 1, 2. Take my ruler. You gotta know the shape. You gotta know the original shape. Draw nice, pretty lines. Give it and arrows. Okay, so I'm going to ask you to graph, and I'm going to ask you to identify all this stuff. So we need to know how to identify all this stuff. First thing, domain. This is the easy one, people. What's the domain? All real numbers, negative infinity to positive infinity. That's the easy one. Okay? Because there's no x's that are off limits on this function. We can take the absolute value of any type of number that we can. Now, there are y's that are off limits. What's your range? 0 included or not included? Is included. 0 to positive infinity. Infinity is not included. You should be using parentheses with those. Okay? The vertex point. According to your graph, what is the vertex point here? 2, 0. Okay? Is it a minimum or a maximum? This is a minimum. I'm just going to make a note of that. This is a minimum. And then what's our axis of symmetry? X equals is how you have to write it. And what's it equal to? 2. I'm going to draw that in just so you can see. I probably won't draw it every single time, but just so you can see here. Now, I want to kind of show you how you can pull some of this information from the equation. Okay? So look right here with me. First of all, this guy, if you have tables, however you move the 0, 0 point, that is always going to be your new vertex point because the parent function is 0, 0. So how that point moves, that will be your vertex point from there. Your x value of your vertex is always going to be the AOS. So like whatever you got going on right here, this guy should be matching. Okay? I want to write something up in this little space right here that I skipped, and this will be helpful for you moving forward. Write this in. The vertex of your absolute value, I'm going to write it in general, which means it's going to be letters, but you're going to see how these letters work as we go through these problems. The vertex of your absolute value can be found in the equation by C, D. Okay, write it down. Meaning you should be able to look at your equation in transformational form, and you can grab the vertex just by looking at it. What do we know about C values? What do we have to do to their signs? Flip them. D values will stay the same. So look here. Look at this equation. What was our C value on number 1? -2. What was the X value of our vertex? +2. Flip C. What was the D value in this problem? 0. There wasn't one. It was 0. What was the Y value of your vertex? 0. So you can kind of always grab that from the beginning because that vertex is has to do with your slides. Okay? All right. Let's try. Y'all try 2. I think you got it. 2 transformations here. Okay, so check number 2. I'm going to freeze the screen. You can start on number 3. Do not go past 3 because there's something really particular that happens on number 4 and one of the other ones. Okay? 3. Again, I'm kind of going through these kind of quickly because these first 3 problems are really like entry level because they've only got like 2 transformations on them. We need to practice a little bit harder stuff, so that's going to be the next couple of problems. There was a b value on number 3, and I'm harping on the fact that the b value has to be factored out. It's going to happen on number 4. On this problem, though, is there a c value here? No. So if there's not a c value, it is just like x has not been shifted left or right, then you don't have to worry about factoring out that b value. It's perfectly fine as is. You can separate it, like put x in parentheses if you want to, but it shouldn't change up your numbers. That's only when you don't have a c value, which is honestly not likely. Most of the time we give you like 4 and 5 transformations at a time. Then there was a shift down. So this one, our range did change in this problem, again, because our vertex point was shifted down 2. So this was our vertex point. And again, you can always see that in the equation. I kind of always do it as like a check. Like, what is my vertex from the equation? And then I check it with my table to make sure I get my rules correct. And then I've got the rest of the stuff based off of that graph. So sometimes I kind of go out of order. But let's look at number 4. And we're going to star number 4 because this is, like, in my opinion, one of the most important questions that you have. We're going to see some reflections on 5 and 6, and those are big too. But this is, number 4 is like a really big intro to kind of what's to come. What's wrong with number 4? Your b value is not factored out, and you have a b and a c. So make that a note. B is not factored out. I'm just going to say never mind. Factored out. So we have to do this first. If you don't do this first, your x's are all going to be wrong. And that is going to be a big chunk of points, and you're not going to like it. So the very first thing that I'm going to do is I need to take out this b value, which what is our b value? 4. So I need to divide out a 4. Now, it stays inside the absolute value bars, but I'm going to reverse distribute here. So 4 times, when I divide 4 out of 4x, what is left? X. That should always be the case. When I divide 4 out of positive 12, what is left?
3.
What kind? Positive 3. Close the bar. Okay? You have to get there first, and then I would mark out that original. Everything you do has to be from this form. This is how transformational form is set up in every single function. I did not make it that way. I just teach this class. This is what they did. These are how our rules work. You have to be able to take out that b value. If there is listen to what I'm saying, if there is a number or a sign directly attached to x and a number after it, you have to do this first, or else it is not going, the rest is not going to be right. Okay, so it's so important. Okay, what transformations are actually happening here? 4 as a b value, it's horizontal. What's the factor going to be?
Compression by a quarter.
By 1/4. 1/4 makes me think compression. I work those backwards because that's how my brain works. Plus 3 as a c value. What is that going to do? Left 3. Let's do the vertex based off of the equation. Remember, your vertex is flip the sign for c, keep the sign for d. What's the vertex point? Flip the sign for c, negative 3, 0. So what's your axis of symmetry?
Negative 3.
How do you write it?
X equals negative.
I'm going to take off points if you don't put x equals. Warning you now. Okay? I'll do the domain and range based off of the graph. My table. What do I have to do to my x's? Multiply by 1/4. Oh, this is going to be fun. 1/4 x minus 3. My y's aren't changing, though. Right?
Yeah.
All right. That's at least nice. All right. Negative 2 divided by, or times 1/4. Well, negative 2 divided by 4 is what I'm doing. So what is that?
Negative 0.5.
Negative half minus 3 is
Negative 3.
negative 3.5. 3 and a half. Okay, and I'm okay with like going to decimals on these because it's mental math and that's hard. 1/4 times negative 1. It's negative 0.25 minus 3. Yeah, I don't know. This is going to be fun. Okay, 0. I like that one. 0 times 1/4
0.
minus 3.
Negative 3.
1 times 1/4. 1/4, 0.25. 0.25 minus 3. Negative 2.75. Thank you, mental math people, for carrying us on these decimals. 2 times 1/4.
Negative 2.5.
Okay. Minus 3. Negative 2.5. All right. Let's put on a graph. It's going to be super exciting. Oh, did our vertex match? Very good. All right. Negative 1, 2, 3.5, 1, 2, 3.25, 1, negative 3, 0. Ooh, this is going to be skinny.
This is a skinny one.
Yeah, it's real skinny. Oopsies. I probably should have changed what I was counting by. I'm not even going to use a ruler. There we go.
Like that, right? Yeah.
Mm-hmm. 0 to infinity. Okay. Okay, so the next two, you've got some reflections going on. And then what is wrong with number 6? I'm going to let you try these two, and then we're going to do words, and then we have to move on to this little thingy that we have to get done today. What's wrong with number 6? It's not factored. Do you remember what I said? If there is ever a negative sign or a number attached to the x and there's a c value, it's not ready to go. So how do you fix that?
You separate it out.
Separate it out. Y equals absolute value. What are you actually taking out on this problem? Just a negative sign. That will leave you with positive x. Negative 7 divided by negative 1 is positive 7, close the bar, minus 4. Okay? All right, try these next two. Be careful with the range. Careful with the range on number 5, because this graph has a flip, so your graph isn't going to look like V, it's going to look this way. So that's going to change up your range. So try these. If you finish these few, there are some word problems to write the equations of. We'll go over those, and then I need to make sure you guys have like 30 minutes to do the pre-assessment thing. Okay, so like I was talking about on number 5. Number 5 had a reflection over the x-axis because that negative out front. So be careful with this. This one's going to be upside down. Be careful with the range. You have to write the range in the right order, meaning negative infinity all the way up to that highest point there. Also, make sure you have your rules set up correctly on number 6. I got that up here on the screen. Here is the worked out final 2 graphs. I'm going to put this on Canvas. If you didn't get to it, that's okay. But you really got to be able, like you've got, this is the practice that you're going to get after we do this thing. 1, 2, 3, 4 transformations. 1, 2, 3, 4 transformations. So most of your problems are going to have a lot of stuff going on. You're also going to have to factor stuff out. Flip over real quick. We're going to do the last 2. 3. And then we'll move on after this. Okay? All right, so what's the equation of the absolute value function? That has been translated 5 units right, 12 units up, horizontally reflected, vertically stretched by 3. This is the same type of problem that was just on your test, but you know you're transforming the absolute value function, which is this parent function. So you don't have to worry about that like f parentheses blah, blah, blah stuff here. You can just go y equals and open up some absolute value bars and just put everything in where it belongs. Okay? If you want to go 5 units right, what letter is that? That's a C. What sign needs to go in front of it? -5. And I'm also going to wrap this guy inside of parentheses just in case. If I don't have a B value, then technically I don't have to have the parentheses, but you're probably going to have a B value, to be honest. Okay, so that checks that off. But it's got to go inside the absolute value bars. 12 units up, A, B, C, or D? D. So what do you do? Where?
Outside.
Outside at the end. Plus 12. Out of the bars. Plus 12. Check. Horizontally reflected. Reflections are negatives. Remember, negatives are their own transformation. And then there's the stretches and stuff. So if it's horizontally reflected, does the negative go inside or outside?
Inside.
Inside. And it's got to be separated by these parentheses like that. Vertically stretched by 3, outside or inside? Outside, flipped or not flipped? Not flipped. There you go. Okay? Try this one.
Don't you have to change the sign?
It's already factored out.
You don't have to make it a plus.
No. Because we wrote it factored out. So in the table, you would have to change the sign, but when you go to the equation, you keep it opposite.
Like if you were going to put it in a table and stuff?
If you were going to put it in a table, yes. This would be negative x plus 5 and then 3y plus 12. Correct. You're working backwards here. All right, what's the equation of the absolute value equation reflected over the x-axis? Where does that negative go?
Outside the absolute value.
In the beginning. Outside the absolute value. Horizontally stretched by a factor of 2. Inside or outside?
Inside.
Flipped or not flipped?
Flip.
Flipped. So what am I going to put inside? 1/2 and immediately open up a parentheses because you've got to write it factored out. 4 units right?
Minus 4 is
Close. 7 units up. Okay. All right, you get to decide on this one. Create an absolute value that has this range. What's the only thing that's going to do to make your range flip? What transformation has to happen?
vertical reflection.
You need a negative A. It doesn't say it has to be, like, you can pick. You can make it a -1. You can make it a -100. So that'll get the negative infinity. What other transformation do you have to have? You don't have to. Well, you can, but what other transformation do you have to have? What?
D plus 4.
You have to move up 4 because that's going to get your graph to shift. Remember, this is our y value of our vertex. So there's multiple answers to that. You make one up there. Okay? I'm going to pass out this practice really quick. Let you look. This practice sheet is instead of Delta Math. Okay? So this is your homework for today. You may have time to work on this after we finish this assessment thing, but just so you know, it's front and back. Graph, find the stuff, write. Another graph, look at number 3. Might make a note. What's wrong with number 3? It's not factored out. That needs to be step number 1. Okay? All right, look up here. You have a check for understanding. It's going to look fairly similar to this, but shorter. Maybe just like the same length of the front page. We're going to do that at the beginning of class next time. So I have the practice sheet here. I will put an answer key to the practice sheet so you can check and make sure you're doing it right. Hopefully I did it right. And then I'm going to post my notes key as well. Okay? That's what we're going to work on. I need you to get your Chromebooks out. And we're going to take this pre-assessment.